Hello and welcome to Physics Pre-AP Semester 2 Crash Course. Okay, so we're first going to go over some of the basics of light, and then we'll get into some practice problems. So, electromagnetic waves, their unit is 3 times 10 to the 8th, and that's just something good to know for all of the equations, like as a constant that we're going to plug in. So a luminous gives off light, where illuminated, it just reflects light. So that's the difference between that. And frequency represents color, and so Roy G. Biv is a good way to remember the color spectrum, which is red, which has the longest wavelength and the lowest frequency of the spectrum, and then it just works its way backwards with orange, yellow, green, blue, indigo, and violet. So violet is going to have a super short wavelength and a super high frequency, so it's just different along that spectrum like that. And then the other spectrum goes gamma rays, X-rays, ultraviolet rays, visible light, infrared, and radio waves. And the difference is the gamma rays have super short wavelengths, and then it keeps getting longer to the radio waves. Okay, so when I keep saying ray and I haven't really explained it. So a ray is electrons in straight lines. And then with all of the math problems, we're going to be working with the angle of incidence and the angle of refraction. So the law of reflection is the angle of incidence equals reflection, which is Snell's law, which is like the main overarching principle of this unit. So when light reflects from a less dense to a more dense area, the angle is smaller. So when light enters air from water, the angle of refraction will be greater than the angle of incidence because it's going from less dense to more dense. And then there's 2 different kinds of main colors for different lights and pigments. So for pigments, the primary pigment colors are magenta, cyan, and yellow. And those are the primary pigment. But then the secondary pigment are red, blue, and green. So then for the light, it's the opposite. So the primary for the light is red, blue, and green, and the secondary for the light is magenta, cyan, and yellow. And so some other really quick formulas I'm going to go over that we're going to be using is C equals N over V. C is the speed of light, N is the index of refraction, and V is the velocity. So whenever I'm going over those practices.
Now we're going to look at mirrors. The first mirror that's going to be drawn is a convex mirror. So the most important thing to know is that you draw through the focal point, then parallel through the focal point, and then through the center. But in some cases, such as diverging, there's diverging in either way. Diverging is in convex mirrors and in concave lenses, and that is where the lines don't extend through and it becomes a virtual image. So we're going to see as these are being drawn that they're going to end up being virtual. And the virtual is shown by dotted lines on the opposite sides of the mirror. And you know that this is a convex mirror because the focal point is on the other side of the mirror as the object. Maddie, can we add music in between my recording and like when I have nothing else to say? Okay, now what's being drawn is a concave mirror. And you know that this one is concave because the focal point and the object are on the same side, which is both in the mirror. And you'll see that you'll have the object right here, and then you'll have the focal point before, so it's being flipped from the other picture. This is a converging mirror, which means it can either be upright, it can either be virtual or real. And if you look, the convex mirror had an upright image, and you'll see what the image is for the concave mirror as well. So it's down right. And those intersect right there. Another way you can kind of tell if it's virtual or not is if they intersect, then no. It's not going to be obvious.
Okay, so now we're going to be talking about sound and just a few facts about sound. We're going to talk more in depth about the Doppler effect later, but that affects the speed of the sound, not necessarily the loudness. And sound travels in compressional waves, and the hotter something is, then the faster that the sound is going to travel. And then loudness deals with amplitude, pitch deals with frequency. So the higher the pitch, the higher the frequency, the shorter the wavelength, and then the lower the pitch, the lower the frequency, the longer the wavelength. And then echo is the sound wave reflected off a surrounding surface back to the listener. We're going to talk more about closed pipes and open pipes later too, but the lower, just for now, lower frequency goes with an open pipe and higher frequency goes with a closed pipe. And then resonance is the vibration of an object at its natural frequency. Okay, so now we're going to talk about the Doppler effect. So there's 4 different equations that you can use. So if your source is moving towards the observer, then your equation is going to be F over 1 minus velocity of the source over velocity of the sound. And that's if your source is moving toward your observer. And if your observer is moving towards your source, then you're going to use the equation that's 1 plus velocity of observer over velocity of the sound times F. And then if your source is moving away from your observer, it's going to be F over 1 plus velocity of the source over velocity of the sound. And then if your observer is moving away from the source, it's going to be F equals 1 minus velocity of the observer over velocity of the sound times F. So you just have to pay attention to your pluses and minuses, and whenever the source is moving toward or away, then you're going to use these two. And then whenever the observer is moving towards or away, you're going to use these two. And then just depending on which way it's going, you're going to either use addition or subtraction. Okay, so now we're going to talk about more in detail about open and closed pipes. So for open pipes, you're going to have, for the first one, which is the fundamental frequency, it's just 1. You're going to have 2 nodes and 1 antinode, and so your wavelength is going to be wavelength equals 2L. And then for the next one, as it draws out, your wavelength is then going to be just L, because in theory you're putting them all over 2, so this one would be 2 over 2, which is just 1. So that's the pattern for this. It's always going to be 2 over whatever your frequency is, so this one would be 2 over 3 times L. And the next one would be 2 over 4 times L. And then next for closed pipes, there's a different pattern because for closed pipes you can have odds only. And so for your first fundamental frequency, it's going to be wavelength equals 4L.
Oh, you're kidding. I messed up. I thought he was supposed to leave very much.
And then for the next one, it's going to be an odd number again, so it's going to be 3, because you can only have odd for close. This one's going to be wavelength equals 4 over 3L. And then your next one would be 5F, so that's wavelengths equals 4 over 5. So the pattern for this one is just 4 over whatever your odd number is for that frequency.
I'm going to do a quick overview of circuits and explain all the formulas. Okay, so first I'm going to be talking about power with circuits. So it gives you P equals IV, but sometimes you might not have IV, so you can substitute in with a different formula to get P equals I squared R and P equals V squared over R. And so you will use the equation P equals IV, use V equals IR. So then you would plug V equals IR into the V right there, which would give you I squared R, and you can figure that out by using all the different things. So now we're going to talk about parallel and series and how to find their total resistance. And so the omega sign is resistance. And so for parallel, you're going to do 1 over each of the numbers. And another way in the calculator you can do it is just by typing the button X to the -1 instead of having to type in the ones. And so you add those up and get that. And then for series, you literally just add them up in a series. So next we're going to do a practice circuit. So get out a piece of paper to work. Okay, for the practice problem, what you're going to start with is you're going to make the parallel into a series. So you're going to do 1 over 20 plus 1 over 60. And when you plug in your calculator, make sure to click X to the -1 to invert it. And you're going to get 15. So now you've basically made that 15 into a series. You can do 15 plus 35, which gives you 50 for the total resistance. Take it step by step to make it easier.
Now I'm going to go over spring and pendulum formulas in addition to refraction.
Okay, so now I'm going to talk about the different right-hand rules. And so for the first right-hand rule, your thumb is going to point in the direction of the current, and then whichever way your fingers wrap around the wire is the direction of the magnetic field. And I'm going to do an example for that in a second. And then for the second one, you're going to do that your thumb is the magnetic force, and your palm is the magnetic field, and then your fingers are the velocity. Okay, so for this one, you know that it's going, because they always go from positive to negative. So you know that your velocity is going to the right, so that's the way your fingertips point. And then in the question it asks for the opposite, so your magnetic force, which is your thumb, is going to be going down. So that means that your the magnetic field, which is your palm, is going to be going out of the page. Okay, so for this one, you know that your B, or your magnetic field, is into the page because X's mean into the page and dots would mean out of the page. So your palm is going to be facing towards your paper, and then the current is going down into the left corner. So your fingertips are going to go towards the left corner, which means that your magnetic force is going to be going to the right corner.
I'm going to be talking about fluids and going through the formulas that we used. So I'm going to be talking about fluids. Fluids, we're going to look at the first formula. Force buoyancy equals the density of water, which is always 1,000, times gravity, which is 10, times the volume. The density of water is always 1,000. Gravity is always 10. So the only thing you really need to find is the volume. Volume can also be found by doing density equals mass over volume. You can move that around to figure that out. So next we're going to be doing a practice problem. So a iron block of weight W is fully immersed in water at the end of a string. The buoyancy on the block is FB and the tension on the string is T. So they're looking for you to, I'm drawing the weight right there, look for the stuff up and down, basically make a diagram. So down is always going to be mg, which is the weight pulling it down. The force buoyancy is pushing it up, the water's pushing it up, and then the other one is tension pulling it up. So since it's not moving, the weight has to equal the force buoyancy and force tension. So you do force tension plus force buoyancy equals the force of gravity. And then you end up changing force of gravity to W because that's the same thing, and you get your answer.
Giabonga Habakale.
Thanks, Mr. Blackman.
Never looking back again. You found somebody who does it better than he can. No more making you cry. No more embrace skies. Girl, we flying on the G5, and we're leaving. Never looking back again. So call you shorty and tell him you found a new man. The one that's so fly. The one that keep you high. Have you singing all night.